I'm Mary Grace Arnaiz, but you can call me Grace. Our topic is about the derivation of the area of a triangle. So, fasten your seatbelts and welcome to the world of geometry. So, before deriving the area of a triangle, let us first find or derive the area of a rectangle and the area of a square. So, what is area? Area is the amount of surface in a region. Does this have a surface? No. Does this have a surface? No. Does this have a surface? Oh, yes. The area of any two-dimensional figure can be determined by imagining its surface completely filled with square regions called square unit. A square whose side is 1 unit long has an area of 1 square unit. The square centimeter is a standard unit of area. Now consider a rectangular region whose length measures 8 units and whose width measures 5 units. How many square units are there in its surface? Let's count. 1, 2, 3, 4, 5, 6, 7, and 8. By counting, there are actually 8 units, and 8 is a product of 4 and 2. Thus, the rectangular region has 8 square units in its surface. The formula for finding the area of a rectangle is given as follows. The area A of a rectangle of length L and width W is given by A is equal to length times width. Now, since every square is a rectangle, the formula A is equal to length times width also applies to the squares. The lengths of the sides of a square are all equal, so its area must be the product of its two sides or the square of a side. The area of a triangle. Consider rectangle ABCD. Notice that a diagonal drawn on the rectangle divides it into two congruent right triangles. So these two triangles have equal areas, and the area of each triangle is 1/2 that of the rectangle. Hence, the area A of a right triangle with base B, which is this, and height h, this, is given by A is equal to 1/2 base times height. After knowing the area of the right triangle, let us now derive the formula in finding the area of an acute triangle. Consider this figure. Notice that the triangle can be divided into two right triangles. In this figure, 1/2 times the base, which is A, and the height, which is H, and this triangle. 1/2 times the base, which is C, and the height, which is H. Adding this to get the area of the bigger triangle, we have A is equal to 1/2 AH plus 1/2 CH. Now factor out 1/2 H. So A plus C. Since A plus C is equal to B here, so A, or the area of an acute triangle, is 1/2 base times height. Just the same. And we are done with finding the area of a right triangle and an acute triangle. Let's proceed to finding the area of an obtuse triangle. Consider this figure. So the area of the two triangles, which is the bigger triangle and this triangle, are 1/2 base, which is B plus A, the height, which is H. And in this triangle is 1/2 A times H. Now to find this triangle, we must subtract from the bigger triangle the area of this. So let's do it. Distribute 1/2 H. But this can be cancelled. So cancel out 1/2 AH. What is left is 1/2 BH. This is the area of the obtuse triangle. Now we have observed that the area of a right triangle, the acute triangle, and the obtuse triangle are just equal. So we conclude that the area of any triangle is 1/2 base times height. I hope you learned a lot. Again, this is Mary Grace Arnaiz. Thank you!